Okay, that last one cut me off pretty close. So here's your second one. Still going to try to fit this into 2 videos, but it doesn't always work out that way. About classifications of matter. So I was talking last time towards the end about this fried egg model, how you're going to fit everything in. Let's get a practice run at this. So sodium is a pretty common element. When I look at the periodic table, I find that sodium is atomic number 11. That means that it has 11 protons and usually 11 electrons. I say usually because it's like base form, and then we'll talk about how things can lose or gain electrons later on. Its atomic mass on the periodic table is 22.989. This is pretty simple rounding, folks. You don't have to get all stressed out about rounding. If it's above 0.5, you round up. If it's below 0.5, you round down. So rounded to the nearest number gives me a mass number of 23. 23 is my protons and neutrons, so I have to subtract my number of protons, my atomic number, from my mass number in order to get the number of neutrons. 23 minus 11 equals 12 neutrons. And then electrons are just 11. But valence electrons are the outer shell of electrons, and they are determined by which group or family you are part of. So which number of the periodic table column you are, which I'll describe in just a little bit, which means that there's 10 interior ones and 1 valence. And I draw my fried egg model. In my nucleus, I put my protons and neutrons. Protons are 11, neutrons are 12. In my electron cloud, I separate out my interior electrons from my valence electrons. So there's 10 interior ones and 1 valence one. We will have a big worksheet with this next on Thursday probably, as I look over at my calendar, so you can get a ton of practice with this. So if this is kind of stressing you out or I'm going too fast, calm down. We're going to get plenty of practice. Some patterns of the periodic table. So this is where I'm going to turn to the periodic table in just a little bit. So from left to right, atomic number increases and mass number increases. From top to bottom, the mass increases, and it repeats every 8-ish. It's a little bit more confusing after the third row because of the transition metals. But 8-ish electrons. And this is because of the valence electrons, specifically because of the octet rule. The octet rule says that almost all elements are happy with 8 valence electrons, and that the only exceptions really are helium. Helium is happy at 2. Now, some more patterns. The columns are very similar. I called them families. I'll describe that in just a little bit. The left side is metals, the right side is nonmetals, and the staircase of metalloids is what separates the two. So let's switch over. By this point, you've already looked at the P table a little bit. So here's what I mean. If I go over to my metalloids, there's my staircase. When I hover my cursor over something, it highlights it. The staircase runs from right under boron all the way down, and then everything above the staircase is a metalloid, and then the 2 that are below are germanium and antimony. That staircase cuts the periodic table in half, kinda. It's not quite equal half. But everything below and to the left of that staircase is a metal, everything, and everything to the right and above is a nonmetal. We also get these families, like some of them even have names, like number 17 up here is the halogens. So everything in column 17 has the same number of electrons. So all of these atoms right here, fluorine, chlorine, bromine, all have 7 electrons. That's the valence electrons, and that's the easy way to find the valence electrons. Column 1 and 2 have 1 and 2. Then you skip all these middle ones. You skip all these transition metals. And you skip over to column 13 here with boron. Everything column 13 has 3, 4 for carbon, 5 for nitrogen, 6 for oxygen, 7 for fluorine, and 8 for the noble gases over here in column 18, other than helium. So there you go. There's your trends of the periodic table. Basically, you just need to be able to read this periodic table, use the information at your disposal. And that's all I got for today. So thank you very much. I was able to fit it in 2. And have a good day. Oh, there it is.